Today's lesson, 3.3, linear or nonlinear. Vocab, they're going to have 3 words for you. Make sure you write these down. The words discrete, continuous, and the word linear. The word discrete. This merely means that you're looking at dots, which are just a few of the values in the interval, and they might follow a pattern or they might be a line, doesn't really matter. But a discrete graph is one that's just filled with dots. So they only have some of the values. We don't choose all the values in the interval. On the other hand, a continuous graph is like a line or a curve. And so you'll see something like that maybe. And this is showing you all the values, not just some of the values. Finally, some graphs are linear. Some functions are not. And this refers to the fact that it represents a line. One thing is that graphs sometimes take time to make. And so instead of looking at a graph, we'll be able to tell by looking at jumps. And if the jumps stay constant, then we know we have a linear function. Okay? 2 examples to do today. The first one here is we're going to start by doing 4 things in this example. And we're going to start with the words, and the words are going to be an output is 3 less than the input. Okay? And to do that, we will make a table. We will write an equation. We will graph the function, fancy word for equation in this case. And finally, we'll ask, is it linear? Okay? So those are the 4 things we're going to do. First thing I'm going to do is take those words and translate it into a table. I'm going to start with the values that we talked about yesterday, 0, 1, and 2, and -1 and -2. And I'm going to plug them into that idea. So if an output is 3 less than the input, if I take 0 and subtract 3 from it, I get -3. If I take 1 and subtract 3 from it, I get -2. And 2 minus 3 is -1. We can start to see a pattern here. And -2 minus 3 is -5. So already we're starting to see this idea of, is it linear? Notice the jumps in each case. They're all +1 on the left side, on the domain side. And then if I look on the range side, those are all +1 jumps as well. So coincidentally, my jumps on both sides were +1. Woohoo! And this would indicate that I'm going to have a linear function. Next, I'm going to write an equation. Almost all your equations will follow this format. There's one other format. We'll talk about that another day. And in this case here, we're taking the x value and we're adding -3. Some people would say -3, and you could go either way. I would suggest writing it as a plus, because you'll want to see that this number is a negative number. Also, it's kind of hard to notice here, but if you look in front of the x, we're multiplying it by 1. And that's not really obvious, but it's a good idea to write that, and that shows us if the function is linear or not. So far we have 2 yeses to the word question, is it linear? Finally, we're going to create a graph of those functions. There's a lot of negatives in this problem on the y. All right, so -2, -5 gets me here, I think. Let's see, there's -4, and there's -2, yeah, and there's +2, and there's +2. Okay, -1 gives me -4, 0 gives me -3. Again, I'm looking at each of these points over here in the table and graphing those points. And 1 gets me -2, and 2 gets me 1. So we start with a discrete graph, and then we bring it in and call it a continuous graph because we were just lazy and we chose convenient, easy values. But in effect, we could have chosen all the values between -2 and +2 if we had enough time, which we don't. Example 2. Oops, forgot to answer this question. Yes, it is linear. Example 2. Does the table show a linear function? And if we look at it here, I could draw the graph of this and answer the question, is it linear? But I'm going to use this technique that I referred to earlier and say, are there equal jumps? Notice in this case, we are going up by 3 in all 3 cases. And as we look on the y values, the range values, I am going down, by 6 every time. And so are they constant in the x? Yes. Are they constant in the y? Yes. So because we have 2 yeses here, we can say yes, it is linear. Okay, hopefully that helps you as you do your homework. Linear versus nonlinear graphs.